All right, we only have two tests still left, and those are the ratio and the root test. I love these because they look really hard, but they're really not, and it makes you feel really smart afterwards. So I really like these. Okay, let's start with the ratio test. If I want to know what happens with the sum of a n, then I can do this rho. That's the Greek rho, rho. That's rho, and I'm going to let that be the limit as n goes to infinity of the absolute value of an plus 1 over an. If rho is between 0 and 1, it converges. If rho is greater than 1, it diverges. And if rho is 1, it doesn't help us. Try something else. So let's use this for example number 1. For each of the following, use the ratio test to determine whether it converges or diverges. The ratio test is going to help us a lot if there's some weird terms in there that I normally wouldn't know what to do with. So like on A, in fact, factorial there, that's really weird. So I'm going to use this to try to do something else, okay? So if I see weird stuff, use that test. On A, sum from n equals 1 to infinity, 2 to the n over n factorial. Once again, I see something weird right there. This is a weird term. If you see something weird, use this test. So what I'm going to do is I'm going to find rho, which is the limit as n goes to infinity of the absolute value. Plug in an n plus 1. So 2 to the n plus 1 over n plus 1 factorial divided by what I had to start with. So that's like saying times, flip it, n factorial over 2 to the n. And let's see what happens there. Let's simplify this. Limit as n goes to infinity. The absolute value sign, everything is already positive, so I'm good there. 2 to the n plus 1 over 2 to the n. I can cancel out the 2 to the n's, which leaves me with just 2 to the first on top. So 2. And let's see what happens between n factorial over n plus 1. So remember what factorial means. So like 5 factorial would be 5 times 4 times 3 times 2 times 1. 7 would be 7 times 6 times 5 times 4 times 3 times 2 times 1, and on and on and on and on. So when on top I have n, and on the bottom I have n plus 1, n means I'm going to do n times whatever is after n, times whatever is after that, times whatever is after that, on and on, right? For n plus 1, I'm starting at n plus 1. You take away 1, you get n. Take away another one, take away another one, take away another one, and what do I see happens? N cancels out, n minus 1 cancels out, n minus 2 cancels out, n minus 3 cancels out. That should have been a 3. Everything's going to cancel out except on the bottom I have an n plus 1. So on the bottom I'm going to have an n plus 1. If that doesn't make sense, let me know. We are going to do a bunch of these, and so it'll help you a little bit, but if it doesn't make sense, then let me know. As n gets really big, the bottom part gets really big, which means the whole thing gets really small. 0 is what I get. So since rho is equal to 0, this converges. Converges. Let's do example B. This is 1b. Sum from n equals 1 to infinity of negative 1 to the n factorial squared over 2n factorial. So once again, this has weird terms that I don't really know what to do with them, so I'm going to use the ratio test. So I'm going to find rho, limit as n goes to infinity, absolute value of -1. Again, I'm plugging in n plus 1 factorial squared over 2 n plus 1 factorial divided by what I had to start with, so times, flip it, factorial over -1 to the n factorial squared. So let's simplify that because that looks like a whole mess, right? First things first, since I'm doing the absolute the values, the -1 terms, I don't even need those there because I'm going to make everything positive. Everything else is already positive, so I'm good there. So let's just simplify it. So let's see here. N plus 1 factorial squared. So n plus 1 factorial is going to be n plus 1 times n minus 1 times n minus 2, on and on. And since it's squared, I'm doing that twice. So this is more terms, and then times, do it again. On and on. 2n factorial is going to give me 2n times 2n. You know what? I'm not going to try to write it all right here. I'm just going to make a whole mess out of it. So instead, I'm going to get another board. N plus 1 factorial squared over n factorial squared. Let's see what happens just right there. This term and that term. So that's going to be n plus 1 times n minus 1 times n minus 2, on and on. But I'm squaring it, so I do it twice. Over n factorial is just n times n minus 1 times n minus 2, on and on. And since it's squared, I do it twice. So what happens there? Cancel out n minus 1, n minus 2, and everything else. And then again over here. So I'm left with n plus 1 times n plus 1 on top, which is n plus 1 squared. Over. Now let's simplify 2n factorial over 2 times n plus 1 factorial. Well, 2 times the quantity n plus 1 is 2n plus 2. So 2n factorial is going to be 2n times 2n minus 1 times 2n minus 2 times 2n minus 3, on and on. 2n plus 2 factorial, start with 2n plus 2. Minus 1 gives us 2n plus 1. Minus 1 gives us 2n. Minus 1 gives us 2n minus 1. Minus another one is 2n minus 2, on and on. So what happens there? Cancel out 2n, cancel out 2n minus 1, 2n minus 2, 2n minus 3, on and on. So I'm left with 2n plus 2 times 2n plus 1 on the bottom. Since I'm taking the limit, I only care about the largest terms. If I squared this out, I would end up with n squared. So the largest on top is n squared. On the bottom, if I times everything out, I would end up with 2n times 2n, which is 4n squared. So 4n squared there. Cancel out the n squareds, and you get 1/4. So the limit is 1 over 4, which is less than 1, which means this converges. Practicing doing all of this stuff is going to help you a lot. Practice is how you are going to get really good at it. And also asking me if you ever get stuck. Example 1c. Sum from n equals 1 to infinity of n to the n over n factorial. Once again, I see a weird term, so I want to do something with that because I don't want to really mess with that. So we're going to do the ratio test. Rho is going to be the limit as n goes to infinity, absolute value. Plug in n plus 1 to the power of n plus 1 over n plus 1 factorial times, and then flip it, n factorial over n to the n. So that's going to be, if I simplify it, the absolute values. I don't really need them here because everything's already positive. So what I do see though is that in factorial over n plus 1 factorial is going to end up being n plus 1. We did that a while ago, right? Because n factorial is n times n minus 1 times n minus 2, on and on, over n plus 1 factorial. That's going to be n plus 1, minus 1, you get n, minus another 1, you get n minus 1, n minus 2, on and on. It cancels everything out except for the n plus 1 here. So end up with n plus 1. N plus 1 to the n plus 1, there's not really anything I can do there. Over, again, n to the n, there's nothing I can really do there. If I look at what my largest term, excuse me, sorry, everything just glitched and I don't know what happened there. Anyway, if we see right here, n plus 1, and I have an n plus 1 here, this is like saying n plus 1 to the first, right? So I can subtract those and cancel out one of them, leaving me with n plus 1 on the top, n to the n, or n plus 1 to the n there on top, n to the n right there. Both of those have a power of n, so I can write it as n plus 1 over n to the n. And if we notice, using everything about math that I know, n over n is 1 plus 1 over n to the n. What did I say that this was? This is equal to e to the first. So just e. E is like 2.71, so this is greater than 1. Since it's greater than 1, it diverges. So again, I'm going to use this test if I have any weird terms that I don't really know what to do with them. I'm going to use that test, the ratio test. Now moving on to the root test. People love this test because it is easy. I'm going to use the root test if everything is being raised to the n. So the root test says, consider the series a(n), let rho be equal to the limit as n goes to infinity of the nth root of the absolute value of an. And then my same rules are here as what I had up there. If rho is less than 1, it converges. If it's greater, then it diverges. And if it is 1, then it doesn't help me. So when everything is raised to the n, I can use this rule because it's basically just going to get rid of that n. So for example number 2, for each of the following series, use the root test to determine whether the series converges or diverges. So for 2a, we have the sum from n equals 1 to infinity of the quantity n squared plus 3n to the power of n over the quantity 4n squared plus 5 to the n. So I know I want to use the root test because everything is raised to the n. So the root test says find rho, which is the limit as n goes to infinity, of the nth root of the absolute value of everything. N squared plus 3n to the n over 4n squared plus 5 to the n. So the absolute value doesn't really help us here because everything is already positive. So that's nice. The nth root and everything is to the n, they cancel out. So this just becomes the limit as n goes to infinity of n squared plus 3n over 4n squared plus 5, which isn't hard. Take the largest term on the top, which is n squared, largest term on the bottom, which is 4n squared, cancel out the n squareds, and you're left with just 1/4. 1/4 is less than a 1, so this converges. Easy as that. The root test is really quick. Example B sum from n equals 1 to infinity, n to the n over the natural log of n to the n. Again, everything is raised to the n, so I'm going to use the root test. Rho is going to be equal to the limit as n goes to infinity of the nth root absolute value n to the n over natural log of n to the n. Everything's already positive, so I'm good there. Nth root to the n, they cancel out, so this is just the limit as n goes to infinity. I'm left with just n over the natural log of n. And as we have already seen, n is larger than the natural log of n, so the top is going to grow and grow and grow, which makes this infinity. Because of that, this is going to diverge. If any of that doesn't make sense, let me know. So now that's every test. That's every test that we need. So after that, the book does a really great job of basically listing which tests you should use at what time. So for everybody in my class, on the note sheet, I list everything out. If not, though, you can hit pause and read all of this. It's going to say when I want to use which test. So go ahead and hit pause and read that. Hit pause or read 4 and the 5 here. For the book, too, our book on pages 517 to 519 lists everything out. It's a really great tool. So for everybody in my class now, and then everybody not, I guess, too, I want y'all to now practice it on your own. So, example number 3, I want you to figure out which of these converge and which of them diverge. So hit pause and work on that. I'm going to tell you what the answer should be. For example A, it diverges. Example B, converges absolutely. For C, diverges. And for D, converges absolutely. So again, try those on your own. And if you need any help, let me know.